Welcome, glad to have you here. This is my second video on solving linear equations for section 1.3. In the last video I just talked about the basic strategies that I use when I'm trying to solve a linear equation, and in this video I'm going to focus on when those equations have fractions or decimals, and basically teach you how you can change an equation that has fractions or decimals into an equation without, and then solve it just like we did in the previous video. Alright, so let's get right into it then. I'm going to go through a couple of examples of equations with fractions, then we'll do a couple of the equations with decimals, and that'll be it. And, well, I should have read the goal here because I'm about to use a word that I put there. My goal specifically was that you're going to learn to use scalars in order to solve equations with fractions or decimals. Now, what a scalar is simply a real number that you multiply, in this case, an equation by. And you can multiply an equation by anything you want to, as long as you multiply every term in the equation by that value. Alright? Now, what we're going to do is we're going to cleverly choose a number that we can multiply both sides of the equation by that's going to cancel out all the denominators in each of our fractions and thereby get rid of the fractions. That's the idea here. Okay, and when you're dealing with fractions, the easiest guaranteed way to get rid of all the denominators is to find a common denominator, and preferably the least common denominator. Alright, so what we need to be thinking about right now is what is a common multiple, so denominator, for the numbers 4, 3, 6, and 8. And it turns out all of those numbers go into 24, correct? So what I'm going to do is I'm going to multiply both sides of the equation by 24. And I made this note over here to explain exactly what's happening here. I'm always with equations with fractions. If I feel the need to get rid of them, I'm going to multiply both sides of the equation by the least common denominator of all those fractions. Alright, now don't get caught up in that scalar word that I use. This 24 that I'm going to multiply is the scalar. And often this is an example of where I show work, even though once you get used to it, you won't actually have to show this. What I'm going to do is I'm going to copy down the equation again. And then what I'm going to do is I'm going to group each side of the equation in some kind of symbol, in this case parentheses, in another case it might be brackets. And I'll simply show that I'm multiplying that side of the equation by that least common denominator, which we said was 24. Okay. And so from here, how do we proceed? Well, what's going to happen then is we're going to use the distributive property. We're going to have to multiply 24 times a fourth x and 24 times negative 2/3, and then we'll do the similar thing on the right side of the equation. Now I'm going to write this out in more detail than you have to. Alright, there's me distributing the 24 on the left side of the equation, and I'll do the same thing on the right side of the equation. And then I want you to pay attention to what happens with the denominators once I carry out all the multiplications that you see. We're going to multiply 24 times 1/4 x, and remember you can always cancel common factors out of numerators and denominators whenever you're doing multiplication, and 24 and 4 are both divisible by 4. That would become a 6 right there, and so that first term is going to become 6 times 1x, or 6x. And then we'll cancel similarly across the way. 24 and 3 are each divisible by 3, so I'm going to do that, make this an 8, and that a 1. So this will be minus 8 times 2, or minus 16 right there. Copy down the equal sign, and we'll do the same thing on the right side. I'll go ahead and do both of the cancelings and then the multiplications afterwards. 24 and 6 are both divisible by 6, so that'll become a 4 and a 1. 24 and 8 are both divisible by 8, so that'll become a 3 and a 1. And so we're going to be left with, let's see, 4 times 5, 20, plus 3 times 3x, 9x. Alright. Now really quickly, the reason that I was able to make it so that all of these denominators became 1 whenever we canceled is because the scalar that I multiplied both sides of the equation by was a common multiple. I guaranteed that 4, 3, 6, and 8 would all go into 24. That's why I picked the number 24, and that's why everything ended up canceling out. which is kind of a good thing to understand. Alright, from here, all we've got to do is follow the same basic steps that we've been using for solving equations. Now I'm going to go ahead and make a new slide and copy this equation over so I've got a little bit more room to work. Now we can go through that SI process that I was talking about in the previous video, where we're going to simplify both sides of the equation and then isolate the variable. Now it turns out we can't simplify either side of the equation. There's no like terms to combine, no distributive property used, nothing like that. So we're at the isolate the variable step. And so the way we're going to do that then is we're going to first collect the like terms, try to get the variable terms on one side. Now I tend to cancel out the smaller of the two variable terms. So I'm going to cancel out 6x from both sides by, well, I'm going to cancel out the 6x on the left side by subtracting 6x from both sides. Of course that will go away and it'll leave you with the negative 16. Make sure you copy down that negative sign. I always use a sign in front of a term. Alright, and then I'll subtract 6x from the right side of the equation, which will leave that 20 alone, and 9x minus 6x is going to give me 3x. Okay? Then we're going to cancel out the constant terms here on the right side by subtracting 20 from both sides. That'll give me negative 16 minus 20, negative 36 is equal to 3x, and then negative 12 is equal to x. Alright, so you see how canceling out the denominators in that equation with a lot of fractions made the equation a very simple equation to solve ultimately. Now they're not all guaranteed to give nice integer answers. Just because you get rid of the fractions from the original equation doesn't mean the answer or the solution can't have a fraction, but still makes the process of finding the solution easier. Let's do one more equation with fractions, then we'll move on to decimals. You can copy this down now. And we'll employ the same strategy here that we just did. What we're going to try to do is figure out what is the common denominator for all the fractions that you see, and hopefully you realize that 5 and 10 both go into 10, and then we're going to multiply both sides of the equation by that common denominator. Alright, so you've already got the equation copied down. Now we're going to copy down again and show that we're multiplying the left and the right side both by that least common denominator 10. And here's a case where I'm going to use brackets to show that. You can see I've got this product, 7/5 times 2x minus 1, and I've already got parentheses involved. It'll look a little bit nicer if I put brackets around that to show that I'm multiplying the left side by 10, and then I'll multiply the right side by 10 as well. Okay, now look at the left side of the equation. It's very important that you notice that the left side of the equation right now is a product that has three factors. We're doing 10 times 7/5 times 2x minus 1. And whenever you're multiplying with three factors, the way that you do that is you just pick any two of those factors and multiply them together, and then multiply the result by the third one. And what I'm trying to say is I'm not doing 10 times 7/5 and 10 times 2x minus 1, because I just have to multiply the 10 by either this factor or by that factor. It doesn't matter which one. I'm going to multiply it by the 7/5 though. Alright, and when I do that, well, we're going to have some cancellations just like we did in the previous problem. The 10 and the 5 can both be divided by 5 and become 2's and 1's respectively. And so on that left side of the equation now, here's what we've got. We've got 2 times 7 times 2x minus 1, or in other words, we've got 14 times 2x minus 1. Now notice I haven't done anything with that 2x minus 1 yet. I'll take care of that on the next step. But also notice that the fraction part went away, and you kind of know what to do with what remains. Okay? And then on the right side of the equation, 10 and 10 are both obviously divisible by 10, and when you divide them by 10, they'll both become 1's. You're just simply left with a 3x there. And just as with the previous example, when we multiplied both sides by that least common denominator, we canceled out all the fractions, and it becomes just a normal linear equation like what we were dealing with in our previous video. And we'll work on simplifying both sides of the equation. In this case, that requires us to use the distributive property on the left, so we'll get 28x minus 14. Nothing to do to simplify the right side of the equation. And since we've already got constant terms only on the left side of the equation, it makes sense to cancel out the variables from there, because then we'll already have the variables and the constants on opposite sides. So let's subtract 28x from both sides. That'll leave us with this negative 14 here. 3x minus 28x is negative 25x. And then we can get rid of the coefficient by dividing. Whenever you divide a negative by a negative, the two negatives cancel out, don't they? It becomes positive. 14 over 25 is equal to x. And if you want to use that old symmetric property of equality that you may have learned before and turn this equation around to make it look neater, absolutely you can. X is equal to 14/25. There's your solution. So now you know how to use scalars, or least common denominators, maybe I'll even say, in order to get rid of fractions within an equation. We're going to use the same idea now with decimals. Okay, so I'm going to show you a couple of equations with decimals, and just like what we did with fractions, we're basically going to make it possible to get rid of all the decimals within an equation and then solve the old-fashioned way like I've just been going over. Except that when you're working with decimals, you might not be thinking about common denominators. All right, here's one of the things I like to do whenever decimals are involved. If the different terms with decimals have differing numbers of decimal places, I like to make it so that they all have the same number of decimal places. So I'm going to rewrite the equation like this. Notice I put a few zeros in there, and the reason I did that is because I noticed the greatest number of decimal places I had anywhere was 2, and so it was easy enough to use zeros to make sure that every term here had 2 decimal places. Alright, now why is that important? Well, essentially whenever you're going through and trying to get rid of the decimals, the easiest and most simple form of how you think about doing that is you say, if I've got 1 decimal place, I can get rid of the decimals by multiplying everything by 10. If I have 2 decimal places, I can multiply everything through by 100. If I have 3 decimal places, I can multiply by 1,000 and so forth here. Every one of these terms has 2 decimal places now, and so what we're going to do is we're going to multiply both sides of the equation by 100, and it's going to guarantee that I don't have any more decimals. So you can see how I did this just the way I did with fractions. I went ahead and grouped the left side and the right side of the equation in grouping symbols, and then I showed what I'm multiplying both sides by. And remember, when you multiply a number by 100, it just moves the decimal 2 places to the right. So that's what's going to happen here. I'll use the distributive property. 100 times 4.25 will be 425. 100 times 2.20 will be 220. And of course there's an x there, and so forth. We'll get 120 minus 140x on the right side of the equation. And then from here, it's the same old, same old. I'm going to go ahead and cancel out the negative 220x from both sides, because that is the least of the variable terms there. By adding 220x to both sides, so we'll get 425 is equal to 120, and then negative 140x plus 220x is going to give you plus 80x. Then we'll cancel out the 120 right here by subtracting 120 from both sides, and that'll give us 305 is equal to 80x. And so then x is going to be equal to 305 over 80. And then we'll just go ahead and simplify that. It looks like we can divide both the numerator and denominator by 5. I don't think anything greater will work. In fact, it won't. 305 divided by 5 will be 61. 81 divided by 5 is 16. That's our solution. Okay, so if you're trying to move the decimal 1 place, you multiply by 10. If you're trying to move it 2 places, you multiply by 100. All right. That's kind of the way this works out. And there are simpler ways once you get better if you got some good number sense, but that'll work every time. Let's try it once more. All right, you see the equation that we're working with, and you see that we have 2 decimal places here, and we have 1 decimal place right there. Now, we can do the same thing that we did in the last example if we like, and it would work out very nicely. We can make both of these terms have 2 decimal places, and then simply multiply through by 100, and it will move the 2 decimal places over. But what I was saying a moment ago is that if you've got some good number sense, sometimes you can actually find smaller numbers to multiply by that will accomplish the same thing. And here's what I'm referring to as your good number sense. Do you know the fraction equivalent for 0.75? It's 3/4. Do you know the decimal fraction equivalent, for 0.5? It's 1/2, right? And if you had a 3/4 and a 1/2, the least common denominator for those two things would be 4. Turns out if we multiply everything through by 4, that will get rid of the decimals. All right, but multiplying through by 100 will work as well, and if you'd prefer to try that, try that. But watch what happens whenever I multiply everything by 4. Okay, now I first want to point out that just like the second example with the fraction problems, I've got a product of 3 terms here on the left side. I'm doing 4 times 3.75 times x minus 4. I'm not using the distributive property yet. What I'm going to do is multiply the 4 times 3.75, and then whatever that result is, we'll distribute it to the x minus 4 on the following step. Now 4 times 3.75. If you need your calculator for this, fine. Assuming you're permitted to use one, otherwise do the multiplication. Here's how I do it mentally. I know I've got 4 times 3, and that's 12. I've got 4 times 3/4 essentially, which is 3, and then 12 plus 3 is 15. That's what I'm going to get when I multiply 4 times 3.75. And then we haven't done anything with the x minus 4 yet. Now on the right side of the equation, I've got a distributive property situation. I'm multiplying 4, or a number, times a sum. And you can always use distributive property when you multiply something by a sum. There's not 3 factors like there are on the other side here. We're just going to flat out do 4 times 2.5x, which I hope you know 4 times 2.5 is 10. So you get 10x. And then 4 times 6 is 24. Voila, we've got it so that we can go ahead and use our basic linear equation solving strategies from here on out. Let's simplify the left side of the equation. Distributive property will give us 15x minus 60. And then subtract 10x from both sides. We'll have 5x minus 60 is equal to 24. Then add 60 to both sides. We'll get 5x equals 84. And so x will be equal to 84 over 5. 16.8 if you use your calculator and realize that you didn't have to round your answer. There you go. That's how you get rid of fractions and decimals to make equations a little bit easier for you to solve. That'll be a great help to you. Thanks for watching. Later.